Welcome to Intelligent Control Group. Today I am going to show you how a resonance can be explained using a simple experiment. For this experiment, I am going to use electrodynamic shaker, amplifier, then a vibrating system plus n vibrating element. Here I used salt and color powder as a vibrating element. Initially I used salt. When I use salt, the vibration look something like this. Here you can see that when I change the frequency, you can observe a particular kind of pattern. Here you can see that a circular or an ellipse kind of pattern, then it will move in a circular pattern. Even if you add some salt, it has some particular path to follow. Now whenever you change the frequency, you can observe that there is a change in shape. So this is one best example. Here one of the main disadvantages that you cannot see the flow of particles because it is white color. So for that purpose I am going to add some color powder in order to see the whole flow of particle. Now I am going to add some color. Here I added a red color powder, and this is amplifier where I can change the frequency, but it has some limitation. For example, here I can change the frequency from 100 Hz to 800 Hz. So this device support a frequency up to 800 Hz. So I can trace only a particular kind of pattern only. If I go beyond 1000, I can trace lot of different types of pattern, but this is the limitation of this electrodynamic set. Now you can see clearly the particle move in a particular way. Now I am adding green color. Now you can see that the green color moving away from the camera. Similarly, it has some kind of clockwise motion about this thread. Similarly, this red color move towards in clockwise direction. Okay, this is the pattern that we are observing by varying a different frequency. Yes, here you can see that clearly. On okay, now my student adding different colors. Here it is yellow. Now you can see that the flow, the way it moves, and the kind of pattern it makes on that surface. Yes, this is a pattern. So this work done by my student as an innovative study for theory of machine 2. Now it is different. Now they are adding a lot of colors on single single plate: blue, green, yellow, red and white. Now I am increasing the frequency as well as the amplitude, and here you can observe that yes, initially it will vibrates like this, then it will form a pattern. When you observe this too close, you can see the vibration of powders. What we used here is a color powder. In Tamil we call it as kolapodi. Yeah, this is another kind of pattern. Some circles, then some curves, parabola and ellipse shapes. Here you can see that there are some particle doesn't have any vibration, but few particle has vibration, then the few particle has some movement. Yes, you can see that movement here. Okay, the particle move along the edge of another color. For example, the blue color move on the edge of green color. Similarly, the yellow color follow the edge of green and light blue color. So this is one example. The main reason for explaining the resonance using this concept is, in real world, how a natural patterns are evolved over a period of time, so are related to frequencies. Why? How the landscape change over a period of time. Why we have a particular shape of land on a particular point, a particular place. So all those things we can explain using the concept of frequency. So each body in this world has some frequency. So because of that frequency, it has some flow. So this is how a nature forms a pattern in world. Even if you take universe, the movement, all those movement of sun, earth, all those things are related to frequency and resonance. Here you can see that, right? An abnormal vibration as well as total movement of particles for varying frequency. Here I can see, I can show only few things, I cannot go further. The reason is we have some limitation. So in this dynamic shaker we have a limit of less than 1000 Hz. I cannot go beyond 1000 Hz. So that is one of the main limitation of this shaker. Initially we used this electrodynamic shaker to study the forced vibration characteristics of a vibrating element in our laboratory. So this is an innovative work. Here you can see that circular shape. Okay, so here our students are trying to clean up the plate using some amplitude. Instead of removing from the plate, they are simply throwing them away from the system by using frequency. Here I have one more example. I already placed different colors near the screw. Now you can see how it moves. Yes, you can see that it will spread. Yes, it has some vibration, increase in dia. Now particles start moving away from the center point. Okay, now it forms a pattern on the edge of the plate. Now yes, see that changes, see the kind of pattern. Yes, you have some bell shape kind of shapes. Okay, now it has some boundary using yellow, light, pink colors, right? When I increase frequency, it will automatically change. Okay, this is one example and this is the final example. Here we have some color, but it is vibrating already. So now you can see that difference. Okay, again you can see the bell shapes. So instead of adding an element on we do vibration, but here we initially created vibration, then we are adding element. So in this way you will get better kind of patterns. See this, you can see the movement of boundary, right? It will increase in depth, thickness as well as movement. So this is one best example for resonance frequency, how a particle in all the objects in real world have vibration, how the vibration influence all the particle or objects in the world can be explained very well using this concept. Yes, even if there is a disturbance, it will try to form the original shape or particular pattern. Thanks for watching my video.